All right, guys, I think we're live now. Good morning, Berlin. Good morning, everyone on the live stream. We have a full lineup of talks today and speakers. It's going to be a more developer-focused day, AI-focused day, and AI tools. So before lunch today, we have myself presenting about Eliza plugins, and some cursor tips. After me is Martin from Coordination Network, and then we have Origin Trail, and Jay from BioAgent, who has another scientific agent project. So let's dive in. We are building on agents on Eliza. It's a framework that has gotten popularity over the past, I'd say, since October, November, but it's been in development much longer than that. They have a new V2 version that's just about to leave beta, and our projects for the hackathon are already switched over to this beta branch, and we'll talk about some details of that today. And then everyone here, through learning about agents and through learning about Cursor, you actually can become an AI developer. Like, it's not that hard now. I think at the end of the talk, you might realize you could go home and start doing these things, even if you're not a traditional developer. So the Eliza agent framework is built on this diagram here. We're really just going to focus on the part of the top, the plugins, which extend the core part of the agent. Basically, the default agent has certain abilities to take certain actions, and how it interacts with the world is through plugins that developers write. And I'll show examples of that in a second. Some other things of note here, really just how the actions an agent takes, and we'll talk about this like action loop, and then the agent in this version can basically be part of different worlds, they call it, and there could be the same agent that basically is living across Discord, Telegram, GitHub issues, wherever you want it. It still has the ability to interact on all those spaces and still retains the same knowledge and memories. Here are just taken from the Eliza OS site. Right now, they have 176 packages, or like plugins live. Just you can see in the screenshot, they have GitHub, Solana agents, EVM, Discord, Telegram. There's a whole bunch of them. But what we've discovered is that really maybe the only scientific plugin that they have right now is for Origin Trail, which is a decentralized knowledge graph, which we're modified and using in our agents. But it's missing the ability to interact with the greater traditional scientific world. Maybe like Dataverse, it could basically interact with all these different tools and scientific plugins, like scientific backends. That could be different cloud labs, it could be virtual screening in silico, it can be maybe your lab has a special backend that it has, and so the agent just needs to have that API hooked up, and then it can interact with some experiment in your apparatus in your lab. But there's really no limit to what's possible and how to connect this. Think of it almost like Zapier or if this, then that. A few different things that help automate agents in the past. You can even get more versatility through plugins and then the actions it enables. More about Eliza, just kind of mental models. We have the agent runtime. We have the services that it can talk over. We have a database. And then for its behavior, we have actions, and then something called providers, where if it's about to take an action, maybe it's about to like either create an experiment plan or submit something to a knowledge graph, it can call a data provider to get more context. And then evaluators are a way to analyze past conversations, or basically it's general thinking to get extra insight into, so you could have maybe like an evaluator that could be a special like scientific model. Maybe like I talked about yesterday, something called like TX-Gemma, which is like a therapeutic drug discovery model. And so you could set this up to be run an evaluation step where that specific model is used for it. And then there's the kind of typical now, like a RAG system for knowledge. RAG stands for Retrieval Augmented Generation, and so this is a way to basically add to and extend what an agent knows about. A few more. Some of these are new in this new version of Eliza. Something called worlds, which is kind of the context and the structure of how the agent is managing who it's talking to. And then within that, you have rooms, which are spaces for conversation, kind of like it could be a Discord channel, it can be a Telegram room. So there's a few things there. And then entities are just an abstraction for kind of like helping it understand the knowledge and the context of who it's talking to. And then the last ones to mention here are tasks, which are kind of similar to like Redis, if you've used that. It's pretty bare bones right now, in a way. So we're working on ways to basically automate these tasks that are running. And so, as I explained, like the multi-step processing, where there's different discrete knowledge tasks attached to like basically the scientific method. We're setting up for these agents to run through multiple tasks, sometimes in a loop, sometimes extending, like going on to the next task. And so that's it. And then lastly, plugins here are what I just talked about, and so they're a big part of these agents. The Eliza, the continuous cycle of Eliza is providers gather context before the response is generated. Then the agent has a set of actions it can take. Some are default actions in the core of Eliza, and then importantly, the plugins it has access to, the plugins that are enabled, give it more actions available for it to take. So maybe it didn't know how to interact with GitHub, and then you just switch on. Super simple to switch on the GitHub plugin, and then all of a sudden it can interact with the GitHub issues and both read and write from GitHub. I'm going to maybe skip through the rest of the slide. It's just, it's kind of self-explanatory. There's entities and components for knowledge and who it's talking to. The changes in V2 for Eliza, just as a note, if the main branch of Eliza is still on V1, they're about to have an official release in the coming days to weeks, but we already have the BioAgent and the BioAgent plugin working on the V2 branch. So I'd ask that basically hackers who fork it, you'll already be using this, and so you won't need to do anything. And then if you're not forking our code, then you kind of have a choice. You'll hear later another workshop from Eliza, and we can talk about that in the Discord, and if you'd like help. And for anyone who's not a developer here, this is actually something that is very approachable, and you can get started. This is basically talking through the documentation that I'm going over. And for developers, you'll find in our own documentation for the hackathon, we've followed this setup here. Basically, the key things to look at in the code are the agent runtime, so just a default project structure that you should follow. The actions and providers are how the agent takes actions of the world. Services are where it's talking, and then plugins are the main thing that we think it's easiest to get started with, where if you have an interest, basically anything that you're an expert in, anything that you're working with day to day, you can write a plugin. Just basically, you fork the existing plugin, and you'll see a few steps to kind of talk to an API, or basically, talking to an API is the simplest way. And then based on the structure of the API, you set up different actions that the agent can take, and that's pretty much it. So these BioAgents have a unified plugin architecture where everything is a plugin. That's clients, adapters, actions, evaluators, and services. Like every single thing is a plugin. And so that's, just the different list here. All of these are in scope for the hackathon. You can basically modify the existing BioAgents or core agents with any of these. And yeah, so any of your ideas, any of your ways to interact with the traditional scientific world, TradSci, like Web2 scientific API endpoints, all these can be implemented. Yeah. Just a few more code details. This is like the plugin interface. You have a way to submit a PR into something called the Eliza OS registry, and then your plugin will just be basically a separate repository inside of the Eliza plugins organization. And this is nice because it allows you to set up separate CI/CD pipelines, and also for a developer, it's really just a binary. You can look at the list of plugins, and then it's just a Boolean to flip them on or off. And through that, yeah, we expect kind of like almost cookbooks to be created, and like recipes for how, because there is a approximate limit on how many tools an agent can have access to. So if you have a list of actions an agent can take, it's basically just a big JSON file where it says like, this is the name of the tool, this is what it does. And so as the agent is thinking, it has some task that it's trying to do, and then it chooses which tool to call from that list of actions. And like anecdotally, and it's been basically around 100, 150 is the limit of how many actions an agent can basically reason through without having more false positives or false negatives as far as like missing an action or taking the wrong action. And so that's kind of gives you an approximate limit to how to encapsulate the agent and how much complexity you can create into the agents around. Shooting to keep it to around 50 actions it can take is probably more than sufficient for the agents right now. Here's just a slide about the plugin structure. Again, this is straight from the Eliza OS registry, GitHub, so you'll find this there. And just one note about how plugins are loaded. They're loaded dynamically at runtime, and so there's a few cool things you can do with kind of variables inside the plugins to read from the local environment. It can read from, maybe it's loaded, you run it with some access to some proprietary data, the plugin can load that in. For our own plugin, this is something that we're encouraging hackers to fork. You can either use this or fork it. And we've created a way that we continuously modify, we monitor a Google Drive folder for new scientific documents. When it detects something new, it automatically transforms those papers into a structured knowledge asset and incorporates them into a knowledge graph. There's basically 3 steps to it. There's ingesting papers, adding them to a knowledge graph, and then traversing the knowledge graph to generate hypotheses. So this plugin handles all 3 of those steps. It shows you how to watch a data source. It shows you how to analyze a paper in that data source to add it to a knowledge graph. And then it shows you how to traverse the knowledge graph and try to basically force an insight out of an agent. You ask it to, just like prompting, you ask it a question, we set it up to force the agent to continuously look at the keywords and assets inside of a knowledge graph and just try to think, kind of like a human does. Like if you have an access to knowledge graph, you try to think about next steps, you try to think about connections between things that are not clear, and this is how hypotheses are generated. And lastly, we've implemented a scoring rubric where every hypothesis that's created from an agent is judged by simply called a judge LLM that has the ability to obviously do some web search and has a rubric for how to do it. Right now, the rubric is very tied to a specific domain around longevity. And so we'll be extending that to more domains, and it's in scope for the hackathon to really improve the benchmarking and the rubric that the Judge LLM works with. All these are inside of our GitHub. The 3 main repos are the plugin BioAgent, the BioAgents, and CoreAgent and the repo is bio-xyz on GitHub. Then I just wanted to wrap up with some cursor tips. Maybe for the room here, who has used, there'll be two different questions. Who has used either like Lovable or Bolt for kind of a design work for AI? We've got a third of the room. And who has used like Cursor or Windsurf for code editing? A lot of the same people, maybe half the room. Cool. These are some tips that I've found. Let me see if you guys it's probably easier to see this on the live stream than here. But this is just what Cursor looks like when you use it. You have the code on the left, and then you have the chat on the right. And previously, this is actually, Cursor is a fork of Visual Studio Code, which was made by Microsoft, and it's very common, just use it for the past decades for code development. And the unique thing that Cursor, the company, added was a agent chat. Well, first it was just a chat, and then they have now agent mode. So yeah, so it has access and knowledge about your code base. And what is just extremely new, it's why Cursor is so used right now, so popular and so prevalent, is that this kind of changes how people code. Like before, it was a lot harder to code fast, and so now you hear about like vibe coding, but there's also experienced developers can also use Cursor to accelerate and both plan. There's something in coding called like rubber ducking something, where you have just like a rubber duck and you talk to it. And before agents and before like the past years of AI, it would just help you kind of formulate your thoughts, formulate your plan. And now, when you use Cursor in chat mode, it's like that, but of course, many times smarter than a rubber duck. And if you use it in agent mode, it is able to change files, it's able to create files, it's able to fix bugs in your code base, it's able to yeah, pretty much do anything at all. And so people are using it to, basically, you can clone, you can download our repository, you can ask the agent to look at it, and you can ask it in plain English, like, I'm an expert in this field of biology, this is what my lab stack looks like, this is what I do day to day. Do you have any ideas for plugins? Do you know how to implement a plugin, how to do all these things? And so you can just chat with it, and you might find it surprising how helpful it is and how it lets you get something working on hour one or day one of this process, which before it would either take a code developer weeks to do the same, or for non-developers it would be impossible. But now I encourage you to think it's within reach. A few more tips is that there's something called user rules and project rules, and these are very necessary to use because the baseline agent that you work with doesn't have any context about either what you're trying to build, or in general, there's extra rules that you can add that show it. And so these are examples of, like, I just took this as a screenshot from what I use. This is like working with Next.js, both back-end and front-end. And so you might think that they're kind of verbose, like it's longer than you would think, but this is helpful. It's been proven, and you can find that we've shared this in our documentation, but you can also find people. Again, it's a little bit more art than science right now, and so there's actually new websites that are just talking about Cursor rules and sharing them for different, either different programming languages, different tasks, and it's super important to use these. And you can also have projects. These are global rules, and you can also have project-specific rules, which are helpful. Another thing is documentation. You can just add new docs if you're using a doc site regularly. You just paste the URL, and it's going to traverse basically the documentation tree and add in all the documentation. And this is, again, just like giving it, this is kind of like RAG, where you're teaching your agent about like the code that you're working with, the documentation, and this is a necessary step for sure. There's something between called chat mode and agent mode, and then for the models themselves, there's something you can enable called thinking. And I have an example here. Actually, go back. So when you use chat mode, it's not going to change any code. And when you use agent mode, it does. And that sounds simple, but you want to, especially the recent versions of, so Claude Sonnet 3.7 is the name of the model that's currently, for all intents and purposes, it's basically the best model for coding. And it has a tendency to change extra parts of the code, maybe adding in comments, adding in things that you didn't explicitly ask for. And so you have to use chat mode first to talk to it and plan out what you want to build, and then use agent mode to code. And when, I'll share the UI now. So this is like the main UI. So there's a few things that are doing a lot of work here. There's the context, there's the agent versus chat in the bottom left, and then there's the model where it says Claude 3.7 Sonnet. And so each of these has important things to know about. For context, just like kind of adding documentation helps it in general. If you want it to really focus in on a specific part of the documentation or part of the code or part of your file structure, you use the context for that. You just like, kind of like mentioning something on Twitter, you just and then you complete what you want it to focus on. And you can add in many different things. You can add in 20 different files. Just basically can explicitly tell it what you want it to care about for that specific question. In the middle, you have the selection between agent and ask. This is basically agent mode or ask mode. In general, you want it to be in agent mode pretty much all the time. But sometimes you can use ask if you're just, that's like the more traditional, like kind of ChatGPT and asking it. When it's in agent mode, it's able to change files and add files, delete files, change the code. And there's a few different settings whether you want. I personally recommend it. The default mode is you have to accept every single change. And so, yeah, it's good to just know what it's both helpful for stopping it from doing the wrong things, but also helpful for just keeping some context on what is changing. For my own context on what is changing, it's helpful. The last thing to note here is this, on the right, there's a button to click called Thinking, where you can turn it on or off. And I recommend always using Claude 3.7 Sonnet, which is the model there. And when it's in thinking mode, it's going to take basically extra time to analyze its own responses. And so when you're asking it to plan, it's good to have it on thinking. But when you're asking it to implement code changes, it's better to not have it on thinking because it's slightly, the code is slightly improved when it's off. And the last thing I'll have an example of is the problem framing, where you should always start by saying, I just want to discuss this without writing any code. And that really puts it in the mode of just thinking and planning about what files to change and what methods to modify. And then once you read through and see what it's about to change, then you say, OK, implement the plan. And it's just going to boom, boom, boom. It can do like 50 different changes and implement all of it. The other thing to note is part of the planning is that you can have either just running it on localhost, or you can ask it to implement a easy-to-check plan, like basically a test plan, for when it does do the changes, how to ensure it's actually working. And here's the last example today is just on the left side, I said, write an overview of the files to change in core to do these steps. And so that's basically in a directory called core. And there's more than just 3 steps here, but it came out with like 7 steps of all the different things to change. And these were all correct. And yeah, basically there's not a lot of trust that you can put in these agents because this in total was maybe 20 different changes to the file base, 100 lines of code change, and there's no errors there. And on the right side of the screen, you just see like, basically how it's able to change the code. And then hopefully, as it finishes a run, or like as it finishes a set of changes, it will explain what it did and share with you. And you can either read it, you can also just copy paste these changes into a file, which basically it's called like a .md file, and you keep track. It's helpful to keep track in case if something does go wrong. There's ways to restore a checkpoint where you just go back and like the code is reverted. You can also save these in order to, again, like basically you can save this in Notion, you can save it elsewhere, and then you have a list of changes that the agent made. And so if it ever is acting a little weird, if it's like stuck in something incorrect, you can just paste back in the previous changes it did, and that just helps it get back on track. I think that pretty much wraps up my talk today. You're going to have, later in the afternoon, another talk from Eliza, from the Eliza team. We just went over how to build an agent and what's the core things to think about when building agents, and then cursor tips. So for any non-developers here, or for anyone just in general, if you download Cursor, and then you download the BioAgent repo, and then you ask Cursor about the BioAgent repo, you're really close to, I can help you today and like throughout the hackathon, everyone's here to help, but like that's just by using Cursor and forking our code, you can be very close to doing something unique and something new related to your field of work. And so we have we're calling like a 2-week plugin sprint for the hackathon, where we have $10,000 US dollars available to the teams that complete plugins in the very start of the hackathon. The hackathon itself it started yesterday and runs through June 8th. So it's about 2 months long, and we want people to build plugins in this first 2 weeks because what people build now are going to be used for scientific outputs later in the hackathon. The greater, basically the scientific world, there's the crypto AI world and the Web2 AI agent world, and right now there's not too many projects trying to bridge the gap. And one of the problems with, as I said in the beginning, the biggest problem is that there's scientific plugins missing. We think there's a lot of low-hanging fruit for connecting the bioagents to traditional science and data sources. So there's lots to build. We're here to chat, and if you have ideas, we'd love to hear them, and then we have ideas for plugins to build as well. So thank you for listening.
All right, do we have any questions? I see one from Slava.
So, yeah, thanks. Great talk. I have a question about knowledge graphs. You know, I'm working with knowledge graphs, and I know a little bit difficulties. So, what kind of triple store you will recommend to work with knowledge graphs, and how you are handling updates in knowledge graphs?
So we have 2 different ways of working with knowledge graphs. The BioAgent plugin itself has a way to set up something called OxyGraph, which is based on it's called the SparkQL knowledge graph framework. We also integrate with Origin Trail, which is a decentralized knowledge graph. And so they have slightly different ways of constructing a knowledge asset. But when we analyze a paper, we go through it and look for all the different entities and create triples from those entities. And something called for biology, there's something called ontologies, and so we attach them to ontologies and then add them to the graph. And that's the quick summary. There's there's a lot of details that go into this.
Yes. So what will happen if triples will change or will be wrong? How you will handle this?
we can either modify the graph with the change triple as well as well, depends whether like your source of authority changing the triple or marking something as incorrect or
Relationships being predicted incorrectly.
Yeah, and when we're setting up these bioagents, we want them to be run in a distributed fashion, and so they're running. Basically, we're writing the code that they're running, and so we have some way to ensure that what the distributed nodes, like distributed agents, are doing is correct. And so we would basically take the updated information as the more recent information should be treated with precedence, like treated as correct in the sense it's always possible to re-overwrite something.
So you are overwriting. No, this is really theoretical question, because if I'm thinking about the blockchain, this information about wrong links, wrong relationships, should be also available for the model, not to make the same mistake next time.
Well, it's almost, well, I think I have to look at it exactly, and again, this is can change. This is for the past few months of development. It's in flux, but it's almost like a stack. For like each node in the knowledge graph can be like a stack where the previous things are not overwritten, but the one on the most recent change takes precedence, or like people can look at the changes over time. But in theory, because we're trusting the modifiers of the graph, something that's more recent could be viewed as the best.
Okay, thank you.
And just to add a little bit onto that, we also are big fans of Neo4j. So if there's anyone out there who prefers that to Oxygraph as their knowledge graph of choice, we're a huge fan. And Slava, we are having a presentation from the Origin Trail team later today, so that could be another great resource to ask. Hadar? No? Okay.
So I have a Eliza question. I'm interested in fine-tuning. Is it possible to take like a local model, then set up like a LoRa adapter and like do some reinforcement learning for the agents?
Yeah, let me go all the way back through the presentation to the beginning. So like 100% yes, but the Eliza framework is almost where would it be? I guess just like in the agent runtime, it's choosing which model to use. That could be GPT-4o, like basically Anthropic. It has an API endpoint that it's calling to get the inference. And so if you have a fine-tuned model, that could be through your own like custom OpenAI model, you would change the URL that the agent talks to. And so the fine-tuning is separate from the agent framework. You just basically point it to your fine-tuned URL, and it would...
Yeah. So like the use case I'm thinking about is if I have a judge that kind of like tells me, oh, the agent did like a good job or not, and then kind of like fine-tune the model based on the agent behavior. So I would be interested in actually like fine-tuning it in the agent framework.
Yeah, and so like the judge, kind of the idea of a judge or like a filter LLM would be that could be either more expensive or have some proprietary data source that helps it. If you have the same AI that creates a hypothesis and judges it, it's kind of you want the judge to have more knowledge, more skill, more intelligence in judging than even the creation. Which seems to make sense to me. So the judge could have a separate, like the fine-tuned inference endpoint.
Yeah, thank you.
All righty, last question.
Hi, it was a really nice talk, but I have a question related to BioAgent and how it works with Eliza. So I have a local setup of BioAgent. I want to understand, like, when you are passing a query to BioAgent, does it pass the query to ChatGPT or Anthropic to get the response, or it does some literature review, summarize the literature and give the response? Because what I got is basically a small summary based on my query. I want to better understand the flow, how it works.
We're using GPT-4o for most of it right now. We like see an easy thing to add ourselves, and like the models you talked about, like if there is a question about a specific like a specific scientific domain, like one of the things in the hackathon, and I mean our own development, we need to give it access to like different models. Like we don't currently have something like OpenRouter set up. I mean, we could point it at OpenRouter, which is a way of changing which model is used based on the query itself. But yeah, something to really want to see explored in the hackathon is using scientific models in the plugins it uses, and see, it can give it, I think, a lot better either at judging or like any different task that's related to a very specific scientific, like a field of science or discipline. Like we don't, it's possible to do that, but we're not doing it yet. It's just like GPT 4.0 for the most part.